Reminder that the next 3 days you don't have class. Thursday and Tuesday, Thursday. Thursday I got meetings Thursday and Friday, along with all the rest of the faculty. And then next week I'm in North Carolina. And it looks like I'm getting swamped by everything at this point. So I haven't done, I think I transferred a couple of y'all's grades across. I really haven't transferred the lab ones over to there, I don't think. I just transferred test grades. So I'm trying to remember, let me look at one thing real quick. I think I've got the permission form from all of you. The online class, there's some people I don't have it from, so. No, I don't have it from everybody in this class. Although the ones that I don't have it from aren't here today. So if I go to transferring grades over to Cisco, I have to watch carefully to notice which people not to transfer on. And then go back through that again later. So that's on that. Because my server class I've gotten behind where I'm trying to do their assignments ahead. I'm actually a little over a week behind on it now. Because they started chapter 6 this week also, just like y'all. And I hadn't gotten chapter 5 done, and I worked on it last night along with trying to answer questions from several students. And I'm only partly through on it and run into a snag on it. And at 11:30 or something last night, I said, when I hit that snag, I went, I'm stopping at this point because I wasn't seeing what I was doing, and when I'll come back to it tonight. The problem is, because I'm using the virtual machines, I've got it set up on the machine at home, so I can't work on it from here, but I really can't work on it very well from here anyway, which is why I did it at home. It's easier to sit there and work for a bit. Y'all, and I've got to go through and update my presentation for next week. That's in there, and then I've got a student from another class that needs some assistance that I'm going to give this afternoon. So that's filled in there. Because she's not getting the help she says she needs from her regular instructor. And I'm trying to give all of y'all assistance. Question came in this morning also, and it might apply to more than one of you, is that if you have missed an assignment, you can still turn it in, but there is late penalty on it if you did. But late penalty is better than 0. Okay? So if you skip something, now if there's some assignment you're working on that there's some glitch we've run into and you've written me on it and that we're writing back and forth and we hit the deadline, it's not going to be late as long as you're working with me trying to fix it. Just like the one where I was helping the student in the server class last night and have emailed him back and forth this morning. Even though it was due last night, he still got to finish the rest of the chapter once we figure out the problem on it. I'm not going to put a late penalty on it until he's got a chance to finish it on up from whatever the problem is that he's been with me on. That although it should be contact me sooner, you should be doing this stuff sooner than the last day it's due on. Because like in that case, he wrote me yesterday morning. I could give a little bit of help, but I actually don't have the book here with me because it's sitting at the house where I'm trying to do it with, and so I was a little bit deterred on being able to answer exactly. And then last night, then it was going through it trying to answer, and then I hit the problem, and I'm hitting the same problem he hit. I'm not sure what that is. So do try to work on the stuff a little bit ahead on it, but I realize at times that you are going to be at the last minute but try not to. It's just like where I've gotten a little behind on it, but now I've got 11 classes at this point because they added one more class on me starting this week. That was the B session. I've got now a intro class also that just started online yesterday. And so I'm getting emails from them also telling me what we're doing. And then I've got to finish setting that one up because I didn't like the way they gave me the course from the other campus, but I don't like the way it was set up. It didn't make a whole lot of sense to me on some things. And so I'm trying to change some things in it to be more logical. Reading the textbook is not lab to me, but that's what they had as lab in their class. So there. So let's look at 6 and talk about a few things in here. I've mentioned already a good bit of stuff that's in here, I think. On this one, we're on the network layer, and we're talking about IP, primarily, I believe, in this chapter, and a couple other little pieces off that. Let's see. So they mentioned to you, in this chapter, they're just going to talk IP. They've thrown out some stuff they used to teach in here that they've put that as legacy protocols, because there were a couple of others used out there. Novell had their own IP type protocol, which is IPX, that they say they're not going to discuss them in this course. But there is 2 versions of IP out there, the Internet Protocol. There's version 4 and version 6. And so we'll look at some differences on those as we go along. And we've already talked about that when I taught you the OSI model and the TCP/IP model. We talked about the encapsulation that occurs there, that when it's encapsulating, it's taking the segment that came down from the transport layer and it's encapsulating it into the packet. So we're dealing with packets on this layer. So remember the packets as the packet data unit. And remember that's where I told you was a confusion one, although, what was it they called it? Protocol data units, what they're wanting to call it now, so, which is better. But you'll see it called packet data units also. Okay? And that frames are packet data units too, or protocol data units. And I like the protocol data unit name better, but it's been so, they've been teaching packet data unit as a term for so long that that's the one that's in my head on it. So even though they're saying protocol data unit, I'm going to come out with packet data unit if I go to reference that to you, even though it is. So they tell you some basic characteristics of IP here. It's connectionless. And we mentioned that before about some protocols are connection oriented and some are connectionless. Connectionless says that it does not make a connection with the destination. It does not know the destination is really there. So everybody follow on that? It's going to send it out there, but it does not establish a connection to the destination before it sends stuff out. So it's assuming it's correct, okay? It is best effort, which relates with the connectionless. It's sending it out, but it's unreliable in its best effort because it sends it out because it doesn't know that it actually got there. So delivery of it's not guaranteed. Okay? So everybody follow on that? So it's not a reliable one, it's connectionless. And it's media independent. That IP is going to work across whatever type media. So it works across them all, and that you're pretty much aware of that anyway, because IP is what's going to be used connecting it across, and that works across whether we're doing fiber, copper, or air on the wireless. So they go through on it. So the receiver doesn't know something's coming to it, and the one sending it doesn't know that it actually arrived out there. Okay? Now, if it gets a message that stuff crashed in the process, that you had a collision, for instance, and the process in the time of when it should have been going to the receiver, it will resend on that, but it doesn't know for sure. It's like just sending a regular letter with the post office. There's no guarantee that gets to the destination. Y'all follow on that? Post office makes its best effort to get it there, because you go drop it in, you don't know whether they've really received it or not. So everybody follow on that? You sent the letter, or when I send postcards from wherever I'm traveling to, I don't know if people got them or not, okay? I put them in the mailbox, and the post office makes best effort on getting it to them, but I don't know whether they got received or not. Of course, the nice part is that if Savannah complains that I was supposed to send her a postcard and she didn't get one from me, I can go, I sent it to you whether I sent it to her or not. And I blame it on the post office that never got to her. Everybody follow on that one? So, post office works good, as an example. It is media independent, like I said, so that's an important one. Now, the other part is we've already talked about the segments getting broken into the size that fits on that network. However, as you travel across, it's going to go across the number of networks in its travel. Okay? Well, it may not go out on, but it's normally going to go out across a number of networks. As it goes across those networks, some of the networks may have, that they may carry smaller transmission units on it. That in the maximum transmission unit, the MTU, is what's the biggest packet can go across that network. And networks are set for different sizes. As it goes across, that when John goes to send it to Savannah, we'll use her again, he may hand a note to me, and then I may hand it to Savannah, okay? The size of thing he can work with may not be as big as I can work with, in which case I'm going to break it down smaller. Maybe John's a lot stronger than me, so he can pick up bigger packages than I can pick up, and that he sets over here this big box he wants me to hand to Savannah, and I go, there is no way I can pick that up. I don't know if John waits or not, but...
Well, is it ever reassembled? Like, so as it comes through and I'm saying, hey, that's too big a packet, then we'll chop it in half, send it out as two, and then you say, well, that's the right size, you're going to send it as two, but then this guy gets it, because I can handle big packets, I'm going to reassemble it. It stays.
It's going to stay small till it gets to the end. Okay? So if it gets split further, it stays split, but it's now segment. Okay? So it will break it down if it needs to break it down further, but remember, it's a maximum. It's not the size. Okay? So that's the biggest that will travel in our network, the MTU. If it's bigger than that, the router's got to break it down into smaller packets and send out those smaller ones. And then when it gets to the next place, if they can handle the bigger ones again, and making a difference to them, because they look at it and go, this is not bigger than my maximum size, so it works fine through my network, so I just keep straight on forward. Good question. And I know what they're doing. They all keep telling you to ask me the question.
I won't be quiet.
So then they look at the packet itself, which is going to resemble the frame that we had before, except for on the packet versus the frame. The order that the source and destination addresses in are different. On the frame, remember, the destination address came first, the source came second. On the packet, the source is first and the destination is second. That's a big one for you to remember on that one, okay? So they've got a number of items they put within it. That the header has a number of different items to it. That there's not the preamble issue that we had on the frame, because remember, it's not actually, the packet's not actually going out onto the wire. It's sitting inside the frame, remember? So we don't need a thing to mark the start of it that it's coming. So we're going to have the version as the very first thing. And so that's going to tell us, is this IP version 4 or IP version 6? Okay? There wasn't an IP version 5. They were started working on 5, and before they did it, they realized they needed some other major changes done, particularly in terms of the size of addresses to increase the number of them, and they went ahead and did 6. So when you keep seeing about, are you using 4 or 6 and going, is there a 5? No, there's not a 5. Okay? But it's not a case of, like Microsoft, that there's no Windows 9, that they just skipped a number. They had actually started working on 5 and went to the other. Okay? And Windows 10 is about ready to have another major upgrade to it coming out. Then I'm going to send out, try to remember to send out to you an article I got yesterday that says we're going to have more control on telling it when it's allowed to update it and when it's not. Because with a feature update, it's got to lock your machine up for an hour while it does its update. And before, it mandated that it was going to do it at that point. This time we're supposed to be able to defer it some on some stuff. But that's still rumor on it because it's not actually come out yet, so it's just on people seeing parts of the advances on it. Then it's got on there of what the header length is. That's not counting the data, that's just the header. And then it's got in the second byte, it's got several different pieces in there, which they're calling differentiated services, or the DIFF serve field, DS. Used to be type of service field, and what it's doing is assigning a priority to that packet. Now, not one that people a lot have anything about, but it's there. Time to live is on there. What time to live says is that it's going to tell us how long will this packet be out there until it's killed. Okay, so when it's sent, that we're putting a value on there, that's going to be in terms of hops that tells us on that. Okay, and so it's going to tell it this is the maximum number of routers to pass through on the way to its destination, which I've mentioned to you before, and it subtracts 1 off each time. When it gets to 0, it drops it. Okay? Now, when it discards it, it is going to not just discard it. It is going to send a message back saying that it discarded it, that its time exceeded. Okay? And send a message back to their sender of it to tell it that this thing got lost out there on the network somewhere. But it's going to subtract 1 off each time, so it's been given a maximum. Here's the amount of time it's going to live. And that we keep subtracting 1 off of it. So it's the opposite of how our lives are. We keep adding 1 to our year each year that we live, but we don't know what's the maximum it stretches out to. In this case, we tell it to start with, here's the maximum it can live to, and keep subtracting 1 off every time it passes through a router. Okay? But like I say, IC is going to send back an ICMP, which is the Internet Control Message Protocol type message back to the sender to tell it, I've dropped this packet because it exceeded the time to live. And you're going to see ICMP used for some other purposes. When you do a ping out there to see whether or not machines exist, it's using ICMP to do that also. So we'll see that one pop up some more. And then it's got a protocol field. And there it's going to tell us about whether it's using, whether this is actually an ICMP or TCP or UDP type field inside it. So it's telling us about the segment on it, okay? This is not the protocol, because remember it said which version of the protocol on the outside. We know it's an IP protocol anyway, but this relates to the protocol for the segment within it. Then the source IP address and the destination IP address. So that's in IP version 4, and that's the one set up for there. IP version 6 has been created and is out there. The big problem with 4 was that we ran out of addresses. And there in the late 90s, actually like 96, must have been 96, it was right before I left Swainsboro Tech, so I'm thinking it was spring of 96 that we went to running out of IP addresses. At that point in time, it was there was an address, a specific address assigned to every machine out there on the internet. So that all of these machines all had regular addresses. But they all had public addresses. And we ran out of how many there were, and that's right when the World Wide Web exploded. Because they had designed IP4 back about 1980 with no thought about the World Wide Web, because nobody knew about it. It hadn't been invented yet until 92, 93. 93 is usually the year given credit on it. Okay? Although it's designed, the initial design on it came like 90, but it was implemented in 93. So 1980, the number of addresses they created with IP version 4, they thought they had everything covered forever. Not literally forever, but for a long time into the future. Having no idea that the internet was going to change completely on how it worked out there. Then that happened at that point. IP version 6 began to be developed at that point, and coming out with, but then we figured out a way to get around it, and we used NAT to solve that one, which is Network Address Protocol. Came out and actually got us by, but IP version 6 came on out at that point, but then we really didn't need it. Now 6 and 4 will work interchangeably out there, so that you can have both 4 and 6 running on your machine. Actually, that's what y'all got on your machines now running. And depending on who your IST is, you may be using 6 in addition to 4, or you may be still just using 4. With Comcast, I know they've got both 4 and 6 running for me out there, and that I can use version 4 or 6 addresses and it'll work fine. It's sitting there working back and forth fine. Federal government computers, all 2 years ago, I think it was, they tested everything. They determined that a few things were not working IP version 6, but everything that's a federal government machine is supposed to be IP version 6 working now, besides 4. So with NAT, what NAT did was it said, okay, instead of everybody having a unique public address on their machines, we'll put a public address on each network and put NAT on the machine that's connecting to the internet from there, and put private addresses on the machines. Private addresses are going to be the addresses that start with 10, 172, 192 out there, okay? It's the numbers you see constantly mentioned in the book and stuff. So private addresses, they don't work on the internet. So we use them as examples. It's like on telephone numbers. What exchange is a private telephone number versus a public telephone number, and it won't really work out there, and that's used in books and movies and stuff? 555. Okay? There is no area code 555. There is no exchange 555. So, and they reserved that out there intentionally in that case's purpose, that they could be used for what I just said. We can throw numbers into movies or whatever, and we're not giving out a real phone number. And so people, that she hears the phone number for Brad Pitt there in the movie, that he gives his number in the middle of the movie, and that it won't work for her trying to call him, and she's not going to drive somebody else crazy about she starts trying to call Brad Pitt. Okay? However, once in a while somebody does put out a real number on it instead. There was that song from the 60s that it used a real number, and every time somebody gets assigned that number, they get driven crazy with people still when they hear the song again trying to call that number. And they'll have to request and get another phone number. I don't know why the phone companies still give it out, but they do. But they should have marked that one, don't use it. Okay? Likewise, on the internet, there are public addresses and private addresses. So what we've done now is, using NAT, NAT will take the ability on that connection to the outside, it will translate that private address from inside when it goes out, change it to the one public address assigned to that network, send it on the machine there that we've made a request for a page from CNN. It sends it on out. It gets it, it sends it back. It's using the public address of our NAT machine connection. Comes back to there. That machine looks at it and says, okay, with the identifying information I put on there and put it in my table, remembering about who I sent to what from, I know this return message belongs to this machine.
I often wondered about that. Is that like in the router says, hey, I want to remember this machine sent me something, even though I'm changing the address. When it comes back, I know that that's going back to that machine.
So it's remembering on it in the using the NAT protocol. Okay? And so it sends them that she requested my web page, she requested CNN, you requested Sports Illustrated, and he requested some game site. Okay? All at the same time, it passes through the router out there. When it gets out there on the internet, they all four look like they came from the same location. Because they came from that machine, the address was changed on that router there by NAT. When it comes back, that router using NAT looks at it and says, it really doesn't belong to me because I've got it in my NAT table in there, and it passes each one of them appropriate back to the right place. That then meant the number of IP addresses we needed dropped tremendously. Okay? So that coming out of the school here, there may be a couple of IP addresses. I think we actually have a public addresses that it sends it out on because we got so much stuff that goes in and out of here. But it's just one or two addresses there it's using. Instead of having to have, just look in this room, 14 addresses were in here. Prior to that, we had 14 public addresses sitting in this one room. Now, you're using one. You'll see where the savings were. That got us from 1996 to spring a year ago. Okay? We've run out of IP addresses again now. Now, there's still some available out there by IANA that assigns the addresses. No longer has any addresses they can assign out, but they assigned them out still in blocks. And that there's a number, ISPs typically still have some addresses to work with, okay? And then they reclaim some of people not using any longer. So it's run out from what can be issued from high up that lower down, there's still stuff there. But if John and I go to start a new company, ISP, we can't ask Diana for some addresses to issue out. We'd have to find somebody else that's got some extras that'll let us sell us, and let us get started.
But almost everything nowadays is IP6 compatible, or not?
There's a large amount of stuff still running IP version 4 out there. It's got, the servers have got to be running 6 for us to be able to use 6 to access. Okay? But it's changing over, so there's a large amount on it, and like I say, as you get the newer equipment, it's doing IP version 6 automatically for you as a general rule. But there are places still running older equipment that they've not got it IP version 6 onto it, or not turned it on.
I was gonna say, is that like in the network card, or is it like, can they get a new driver for an old card and make it IP6 compatible?
Basically, anything that they've had since the early 2000s is going to be 6 compatible. Okay? Windows, starting with XP, has been IP6 compatible. XP, you had to turn it on. Since XP, IP version 6 is automatically turned on for you. Okay? You can turn it off if you want, but it's automatically. So we're moving to the point where everybody will be able to work with it. So NAT gave us a solution around it. Okay? Now, IP version 6, we don't need NAT anymore. IP version 6 gives us 4 quintillion addresses, I believe it is. I remember my number right. Basically, we can assign an address with IP version 6 to every grain in the sand in the world, is what they say. I'm not sure about that part, but that's what I've seen cited. But you've got a ton of them out there. IP version 4 also had the problem of, when we actually look at the addresses, we'll see there was a huge wastage in it. That they had a lot of addresses got wasted, and the way it was designed wasted a lot. And there in the late 90s, they cleaned up some of that. It's still that way set up, that they quit. They were issuing people, if you were a larger organization, if you needed more than 65,000 addresses, they gave you 1 million addresses. Okay? If you needed more than 254 addresses, you got 65,000 addresses. That had big wastage there, so now we don't give out those numbers. It breaks it down. We're going to talk about subnetting to get around that one. So address size is going to go from 32-bit to 128-bit. It's going to be expressed in hexadecimal instead of in decimal on it. They actually made the headers better to make it work better, and we don't need NAT anymore. And it's actually going to work off the MAC address in your machine to assign addresses to. And we already had that whole unique number for all of our devices out there anyway. So it's going to use it as part of that IP version 6 address. So then they mentioned there, it gives you 340 unidillion, sorry.
Unidillion, yeah, I knew it was a word I'd never heard before.
And they show you where you can go on up a ton from those things. So that unidillion gives us, it's 10 raised to the power of 36. So its packet is going to look a little bit different than the other one, but it's going to be basically the same. One is expanded on some of the fields on it and changed a few around slightly, but they're basically the same as what you had in the IP version 4 one. Again, it starts off with the version on it, because then that decides what's the rest of this packet look like. And that they did add a new field there, or the flow label on it, but the big parts are the version's still there, so it's going to have a value on it. Actually has a binary value of 6 on it to tell it it is version 6. Oddly enough, they actually managed to get the right number on it. And then their traffic class one is the same as what they had as the DS field over on the other one. The flow label just tells it to the router about how to handle on it. The payload length is what's the length of the data in there, which was a segment, remember? And then the next header is the same as the protocol one, which tells it in terms of what protocol is that data using. And so it's telling you the next header within the frame, within the packet, because there's a second header in there that's sitting on the segment. So that's why it's next. It's got hop count instead of time to live. They called it time to live on 4. On 6, they call it hop count. That's really what it is. Because actually some other ways that there are some other protocols that will have different time to lives that you look at on some higher level protocols that have time to live that's different than hop count. So they've actually called it hop count now on IP version 6. And then the source IP address and destination IP address. Obviously 128 bits versus 32 bits. Loopback interface, they mention about that you've got a loopback interface on the devices, and that's where you can send it out and test, that you're just sending it to your interface to test if you can reach your actual network interface. IP version 6 has one address reserved for that. It's the only IP version 6 address I can tell you off the top of my head. It's 127 zeros followed by a 1. Okay? They reserved one IP version 6 address for loopback. IP version 4 gave you a ton of them, somewhere around a million of them. It was anything that started with 127. There's one of the inefficiencies of IP version 4. Okay? They wasted a whole bunch of addresses there that they didn't need to waste, but they weren't worried about it. They didn't know all of this demand was going to come on. But it's just a way of checking itself, and that you will ping it sometimes. You could ping 127.0.0.1, actually 127.anything.anything.anything, as long as it's between 0 and 255. And what that will do is look and see, can it reach your network interface? If you get a response back, you can hit your network interface. Doesn't tell you if you got connection any further than that, but you know that you're hitting your network card. Does everybody follow on that? So it's a good testing ability if you're not getting, it looks like you're not getting any traffic out to there. You can find out first, can I get to the network card, or that you may start from the far end and work back in, or you may start from there and work outward and see where can you get to. Default gateway, I've already told you about that one. That's just where does it send it if it doesn't know where this address is. Okay? And you set up the default gateway there when you set up your devices. That you tell it, all right, if it doesn't know, if our machine doesn't know anything about that address, what address does it send it to? And that's all the default gateway is. It's just where to send if it doesn't know anything about the address. The routing tables, it talks about that there, and that the routing table keeps track of the addresses it knows about where is those out there, which interface is what address located on. Of what interface coming off that router do we send stuff to? If we know the IP address, which interface does it go out on? Okay? Doesn't mean that IP address is sitting there on that interface. It just means we know that if we want to send to this address, we know it belongs on this interface to go out to get it going to where it's going. Those get updated constantly on it. You can have host and dynamic ones. Netstat is the command that will show you your routing table. And you can actually use that on the PC or on the router. Okay? So you can actually look at your routing tables both places. There is P version 6 routing tables and IP version 4 routing tables, obviously. And they talk about how it forwards it through, which I've already told you about. In the routing table is going to show you items that are C, and that when you look at it in the router, it's going to have some items listed with a C on it, and what it's saying is this is directly connected to this device. So it's on the network, hanging right on there. It's not passing it on to somewhere further than that. So a C entry on it says this is one that's directly connected here. And L is that's the local interface. We're talking about the interface on that router. The C is the big one to remember of those. And when you look at the routing tables, and I think you do in your lab in this chapter, that you'll see that on there. And then they show you some others that could be shown on there too. But the C tells you, is it directly connected? Or L, did it learn it? So the L makes sense to you in terms of that. The C is telling us it knows this is absolutely right because it's directly connected to it. The L is when it learned from somebody else. And that's again, think in terms of real purposes. If it's something you know about specifically from your experience, that counts better than where you learned it from somebody else. It may or may not be right. Okay? So we're back to that whole big thing out there currently of fake news versus real news. And trying to determine, but then it's trying to determine what is really fake and what is really real. But if you know, if you were there and watched the accident occur, you know that's what really happened. If you're going by what I told you about the accident, well, you're not really sure if that's correct or not. You're going, okay, Dr. Watt's reliable usually on giving the information, so I think it's correct. Because it came from him versus it came from Joe, that we've learned over time that that's not always fully reliable what he tells us. He can embellish a story well. Then they talk about routers, and routers are really computers, okay? It's just a computer with 2 or more network connections. Does everybody follow on that? So that router sitting back there is actually a PC. Does everybody follow on that? Limited, so it's actually a PC, okay? It's got a CPU in it. We know about the memory in it. It's actually got it as a card in these, etc. to it. And it's got an operating system running on it, because y'all have already seen that it's using iOS for an operating system. You could use just a regular PC for a router. As long as you've got 2 or more network connection cards in it, it becomes a router. Still, it's a PC for you, but it will actually be a router. If any of you are using satellite internet, the machine that's connected to their device to connect to the satellite, they actually have you use as a router sitting there, because they have you put 2 network cards into it if you're going to have more machines connected to it. It's got to pass through one machine passing on out to them. And they'll make you put 2 network cards in that machine and connect to your one card connecting to them and one card connecting to your switch. Connects to the rest of the devices. That PC, which you're still using as a regular PC, is actually a router now also. And then they show you some pictures about what's in there and everything, and it's similar to your PC. It's just very limited on it because it doesn't need to be real powerful on it like PC does. It's just doing network traffic on it. And then they show you about connecting up to it. We've actually talked about that already, about the connections on there. So I think you've got that part already. Booting up, we've mentioned that on it, that you've already seen. It starts with the flash, and goes to the NVRAM from there, and gets it Does it flash? It starts the iOS, looks at the NVRAM to get the configuration that's specific for this machine, and then it starts on up. And you've seen some of that already, so there's that. They mentioned about the show version command, which will tell you what version of the iOS you're using. And so they're up to version 15 now. Our routers may be still sitting on version 12. I'm not sure if some of them have gotten updated or not. But there's not a big difference on it. Then they go into configuring the router. You've already configured a switch back there in the beginning, remember? And it's going to be the same type of thing as you did on the switch. There's a few little different commands, but it's going to be the same type of thing. You're going to do the enable command just as before to get into the privileged mode on it. You'll use the config T command again, just like before, to go into configuration, and that you're going to use similar commands on down through there. So those are all going to still stay the same type thing too. A little bit different being on the router versus the switch, but they're almost the same, and most of them are the same. But there are a few different things different. Remember, there was a command we tried to use in here that actually was for the router and not the switch, and I was sitting there telling you on the interface command. So now you can use it. Message of the day still works the same as she's already saw it on the switch, etc. Then they go into configuring the interfaces, which is where you're going to use they show it to you in the book as interface space gigabyte Ethernet, spelled all the way out there, and remember you can do it instead as INT, and the gigabyte Ethernet can be just the letter G, and then you tell it the number of the interface on it. Or if it's not the gigabyte one, it's FA for fast Ethernet. So you can abbreviate those down pretty good. And then you can show your interfaces with the show IP interface brief. Again, you can abbreviate interfaces INT. Brief will actually abbreviate as BRI. And it tells you what your interfaces are. You want them up and up, which I mentioned before to you, but I'll mention for sure now to you. First up, it's telling you about whether it's physically there. The second one's whether the protocols are working on it. And it needs to be up and up. And remember, on interfaces, you also have to start them by using what command? No shut. Okay? You start the interface up by doing no shutdown. But you're using a double negative to do a positive. Don't tell your English teacher I told you have to do a double negative. But that's the way they designed it. So to start it, you do no shutdown. Sort of like on Windows. If you want to shut down Windows, what do you click on? Start.
Used to be start.
Okay.
It used to be start, now it's just
It's still the
a
start
flag
button.
or something.
It's still the start button. It's just, it doesn't say start now. It says you go to the start button to shut down. So to shut Windows down, you go to start to shut it down. On the routers on Cisco, you do no shut to start the interfaces up. And then they show you about configuring the default gateway on Cisco, on the router, to configure the default gateway. That is that you're going to use an interface of 0.0.0.0, 4 zeros. It's a quad 0 is what you'll see it called quite often. The default gateway is the quad 0. So if you see something mentioned about quad 0, that's the default gateway they're talking about. And so you will use that. I don't think they actually tell you quad zero here, but usually they do. But it is the 0000 is what you're assigning it as. And that there is chapter 6. Questions on that? Now, the nice part about where we're 7, which, is that next week or not? I don't remember how many
Yeah,
weeks.
6 is due Monday.
6 is
That's
due Monday. And I'm not sure, is 7 1 or 2 weeks?
7, I think, we're back to 2 weeks.
Is it on 2 weeks? I hope it's 2 weeks. If it's not, we're going to spend, I'll probably just adjust the schedule anyway. Because I can always put things off, okay?
7's not due till the 20th, so it's 2 weeks.
It's not due to the 20th, okay. So it's got 2 weeks on it. So we've got that week when we come back to cover on 7, good.
That
but
says, it says Monday cabling lab, but is our cabling lab going to be?
in the midst of there, that I put the date of the 13th out there, is it the 13th or the 6th?
13th.
The 13th. I put a date out there for it, that's for the online students, although I'm really I've got to put out there and tell them I'll do it that week actually. We're going to do the cabling, should do the cabling that week, one of the 2 days, okay? Along with go over the IP address. But I've got a date out there on it for the online ones to stress at them that they've got to get it done. So I'm going to put a note out there to them, which I'll probably to tell them that they can do it that week. So I'll probably really go out and change the deadline on that to the 20th. But it's got to be done, but we'll do it in here probably that week, either on Tuesday or Thursday. Okay? And I'll have y'all make the cables that we'll use one day or part of the day, however long it takes for y'all to do them. Usually it takes the day on it. Because you may go through and demonstrate it, and y'all sit there and make the 3 cables. And then this time is all the assistance you need between me and the classmates to get them made. And then at the end, the last week, we'll come back and do them again. That time, that y'all can't get assistance about losing credit. But you've already done it, okay? So that's usually simple for everybody. And that you'll be able to, and so you'll do the same thing again that you already did. Is everybody following that? Now, you don't have to remember the color code memorized. That I'll let you either have a note written on it or I'll have it written on the board. Okay? And so y'all can have written notes on it. But you can't ask for somebody to tell you or show you or whatever at that point. However, I will let you ask me if you can ask me a question whether it's going to cost you points or not. Because it may be that you've run into something that I didn't really cover. Okay? In which case I'll tell you that it's not going to cost you anything for me to answer that one. Or that if I answer it's going to cost you some points. And then you can decide whether you want to ask me or not. So ready? Understand that part? So, but when we do it week after next, ask everything you want to ask of me or whoever's around you. Okay? To doing it. And then and the other part is you're going to test them. And I'm going to show you how to test them. So before you bring them up to me to be graded, you can test to make sure it's correct also. So you should have it correct when we go to check it off, and I go to check it off. It counts as a lab grade. The one that you're doing next time will count the same as the packet tracer assignments. The one at the end is 10% of your final grade. Because that's what I got about the lab final. That is the lab final. And that's 10% of your grade. That's 10%, you should get the whole 10% on it. It's very seldom I ever have a student that doesn't get hundreds on it. And it's a case of the ones that didn't get 100 on it just absolutely did not pay attention or whatever in class, doing it, etc. And that I knew they were going to have problems, that they sat there and didn't do any paying attention and did it, but really didn't know. Then didn't, when they went to do their final, that they didn't have any bit of paying attention how to do it. Had to get all kinds of help to get it done. Okay?
I've got a quick question about IP4. You know, it says it's connectionless and basically doesn't care if it gets there or not.
Mm-hmm.
And that's just IP4 though, but it works with like the transport layer and everything else to, you know,
That
so
is,
just IP4
other
doesn't
layers
care.
are looking, other protocols that may be also involved on the other layers may be actually making sure it gets there.
Right.
But IP's not concerned about that, but
Just
some
concerned
stuff
with
you're
the
sending
sound.
out there, you really don't care about. You're just trusting it gets there. Okay? But as far as if it needs to be trusted about getting there, that's going to be done on another layer.
But it still could include IP4.
But it's still going to use IP4 as its way of going across all that. Okay? But another layer may be confirming that it really is there. The TCP, if it uses TCP, TCP is going to make sure it got there.
So that's why they say like TCP/IP is the transport layer.
Most often you're using those two, but you could be using UDP and IP. And UDP is going to be connectionless also, and not guaranteed. TCP is going to guarantee delivery. So if it needs to be guaranteed on delivery, TCP's already taken care of that. IP doesn't need to worry about that part. Okay, so when we get to like chapter 9, I think. Yeah. We'll look at TCP versus UDP. But 6, 7, and 8 we're dealing with IP. 6 we looked at IP, 7 we're dealing with IP addressing, and 8 should be subnetting. Yep. So 7 and 8 merge together. All right, any other questions on that? And I will be online every evening next week. It's just, I won't be during the day, because I'll be in class all day, or teaching all day, so I'll be in class whether I'm taking or teaching. And then that I will at some point in the evening get online and answer emails and everything else. Monday evening probably get quicker onto it because we just have a meeting during the day. But I'm going to be staying, I think, about 40 miles from my motel that first day. And then the meetings the next days, I've got to get to the motel still. That's what I've got to do when I get out here. The next days that my meeting will be near my motel, so I won't have a drive. But that's the object. Is Monday's meeting is 40 miles away from the other meetings. I'm just going to stay in one hotel for the week instead of moving hotels. So I could check in and check out, and I'm going, why do I need to go through all of that? I can drive 40 miles easily on Monday each way from the hotel. And that way I can set stuff up in the hotel and it's sitting there, and I don't have to worry about trying to pack up that Monday morning to head to the meeting and then unload again that night. To me, it's easier that way. Now, some other people at the conference with me are going to switch on Monday night. And Tuesday night, I've got a dinner, that they've got a dinner dance for us that they said for us to have that evening. And so I probably won't get back to the hotel till 9 o'clock or later that night.